All right, volumes of solids with known cross-sections. Consider R the region on the right. This region is the base of a solid coming up out of the page. Okay, so it's a two-dimensional figure right now. I'm looking for my rectangular eraser here. But off of that flat area, we're going to build some things like up out of the page. And so the only thing I had handy was there's a rectangle. So there's a rectangle coming up out of the page. All right, you can kind of see that when I move the camera around. There's a rectangle coming up out of the page. And if there was a bunch of rectangles coming up out of the page, then this thing would have a shape and there'd be a volume there. You can see, hopefully you can visualize the pictures down here a little easier. This one has squares coming up out of the page. This one has triangles coming up out of the page. This one has semicircles coming up out of the page. The point is we're going to build some solids, some volumes, based on a base and a shape coming out of the page. For this solid, we know the shape of every cross-section perpendicular to the x-axis. We like perpendicular to the x-axis. That means it's a dx problem. It's like whatever shape we have, its thickness is dx. Now, the cross-sections might be squares, or triangles, or semicircles, or any other shape. Some will be smaller than others. If the cross-section is in the middle of the graph, the shape will be large. If the cross-section is on the ends, the shape will be small. See if I can draw this. I'm going to draw semicircles. So there's a semicircle coming up out of the page. And if it was even nearer to the end, it could be a really small semicircle. And if it was right there in the middle somewhere, that would be a big semicircle. And so part of the trick of these problems is understanding what they're telling you, and can you visualize what's going on. And it's hard, well, it's always hard to draw a 3D picture on a 2D graph, but certainly with shapes it's tricky. The big deal is that each cross-section has the same shape, right? It's not squares and triangles and semicircles. They're all one of the shapes. Again, there's some pictures. I think this left off the word square, because those are square cross-sections on that first one. The second one's equilateral triangles. The third one's semicircles. The good news, kind of good news, is that the volume formula is, I don't want to say it's exactly the same, because you know that's not exactly right, but the format of it is the same regardless of the shape, because the format is antiderivative from A to B. On Friday we added up all the rectangles, we added up all the height times width. Today we're going to add up all the area times width. So width is easy, that's still dx. But instead of just a height, like a rectangle, there's a whole area to consider. And that would be the area of the cross-section. So all the cross-section problems will use this formula. Again, that's a little misleading because the areas are different, so what goes into the formula is different, but the format is the same. We're adding up all of those slices. So like this semicircle right there, it's got a thickness of dx, it's got an area of 1/2 pi r squared, and so we multiply 1/2 pi r squared times dx, that gets us the volume of that little slice, and then we add up all the slices. So we're going to spend a couple minutes. We'll spend a couple of minutes reviewing. I'll go back and fix all those later. The area formulas. I pick on people for this. What's the area of a rectangle? Base times height, base times width, length times height, whatever you want to call it. So this one is not, they usually have to give you more info if they ask you for rectangles. Because you'll know one of the dimensions, but you won't know how tall it is. So the thickness will be dx, but the height, and sometimes they'll just say the height is 5. Sometimes they'll get crazy and say the height is 2 times the base. Right? Square gets a little easier. What's the area of a square? I'm going to say s squared because usually s is going to be the distance between the two curves. So that distance is s. Because we could be building a square out of that. So s squared would be that area. Equilateral triangle you probably don't know. I bet if I gave you enough time you could figure it out. Because it's 1/2 base times height, but you got to figure out the height, and there'd be trig involved, and sines and cosines. So you probably just want to trust me that it's root 3 over 4 s squared. That one gets boxed, starred, because you probably don't know that one. You probably need to memorize it. You can figure out a rectangle and a square without too much difficulty, but equilateral triangle, that's a little different. What's the area of a semicircle? 1/2 pi r squared. Yes, not wrong. But what if I don't know r? What if I know the diameter? 1/2 pi times. What's the radius of this circle? Half of the diameter, so s over 2. And then if I square the s over 2, I get a 4 in the bottom. I can combine it with the 2 out front. And here's where you kind of have an option of what you want to, whether to memorize or not. If your brain has space for more memorizing, then pi over 8 s squared. If you don't want to memorize anything else, then you can always start with 1/2 pi r squared, because you know it's half a circle, and then figure out that, well, r is s over 2, so there's my formula. And usually we're going to the calculator anyway, so even if it looks weird or crazy, calculator can do it. So this sort of gets a question mark, like, well, do you want to memorize that? Might it save you a little bit of time? Maybe. Is it worth memorizing? I don't know. I usually don't memorize it, only after I've been doing it a couple days and it comes back to me. But if I get a problem that I haven't seen in a while, I'm going to start with 1/2 pi r squared and kind of figure it out. All right, isosceles right triangle with a leg in the base. So that means that's the base, and that's the base because it's isosceles right triangle. So this is kind of an easy one. What's the area of a triangle? One half base times height, or in this case, 1/2 s squared. But I'm not like highlighting that one because you don't have to memorize that. I think you already know that. Isosceles triangle, hypotenuse on the base. So this time the base, that S, is the hypotenuse. This one, again, you could go through some trig to figure it out. Here's how I usually figure it out, because I don't memorize this stuff. I could picture a full square. How much of my square is shaded? 1/4. So 1/4 S squared. So that's another one where, like, do you want to memorize that? Maybe. Or you just want to look at it and figure it out? Probably not. You definitely need to memorize root 3/4 S squared, because that would take too long to figure that out. Good, but it would be way too long to sit there and play with it if you figured that one out. Pi over 8 S squared is convenient, but not necessary. The others, I think you already know. Okay, as you turn the page and we get ready to do a problem, I want to show you a little bit of what I linked in the So in the document that's got the videos of the lessons, I've also included some more stuff in there. So some pictures. This first one is pictures. So I don't know if you can see that. That's y equals x squared is the base. So that base area is the area under a parabola. And then this person built 4 different models. This one looks like there's squares coming out of the page. This one looks like some kind of triangle coming out of the page, rectangles coming out of the page, and semicircles coming out of the page. So that's on there just to help you visualize what's going on. Emails from Miss Ray. We don't need to see those. Video of, let's see which one this is. Replay this. So this one's kind of interesting. Hit play. Skip past the Snow White movie. Whoops, that's not the video I wanted, I don't think. Let me go back to this one. Again, you got links to these, so we're not going to watch all of these. There it is. This guy it looks like the base is a semicircle, and he's building a semicircle off the top of it, so that's kind of weird or confusing. But in whatever software program he uses, so there's a semicircle. This guy can grab the graph and rotate it around, so it helps visualize what's going on. In a minute, he's going to start, building the semicircles, building the volume. In a minute, he'll grab it again and start moving it around, so you can maybe visualize what that shape. There's the top view. Oh, that's not even a circle, that's an ellipse. So he's trying to just visualize what that shape looks like. Kind of interesting. And then there's one more video, square cross sections being built. This one's kind of cool because he's got the 2D version on the left, so there's just the regular old parabola. And on the right, he's going to be building square cross sections of it, so you can see the 3D of it over here while he's just tracing out. This is a top view, so you don't see the squares. There's the 3D view of it. So you can Google this stuff and get some pictures to maybe help understand. He's doing it again with, this time he's labeled it dy. Got some formulas on there. But I really wanted to just see those for the visualization aspect of them. All right, let's go back to number 1 here. Region R is the solid bounded. I don't know. Now you got me confused. Which one's better? Solid bound or bounded by the graphs of y equals x minus 4, y equals 4 minus x, and x equals 0. Okay, x equals 0, that's an easy graph to know. X minus 4, that would be the one that starts at negative 4 and has a slope of 1. In fact, I'm going to call that y1 because these may end up going into the calculator. y2 starts at 4 and has a slope of negative 1. 4 minus x. And so there's our base region. On Friday, we would have found the area of that. Top minus bottom from 0 to 4 dx, that'd be the area. But this time we are going to do cross sections perpendicular to the x-axis. We like that, so our slices will be a dx slice that are equilateral triangles. Okay, so this is hard to draw triangles on top of a triangle, but going to have triangles coming up out of the page. Okay, so now I'm going to add up. That's what the elongated S means. Sum up all of the triangles, the area of triangle. We already said dx. So we probably should get some x limits on this. So from what to what? From what x values are we adding up our triangles? 0 to 4. Can't see it very well, but that's 4. So yes, 0 to 4. All right, the area, some of you were flipping back to see that the area of a equilateral triangle is root 3 over 4s squared. Now I need to figure out what S is, how long S is. So S is that distance. Sort of relates to what we did Friday. How do I measure what S is? Let's see. I'm just going to, for now, I'm just going to say it's top minus bottom. Looking for a ruler, and I don't have one up here. Top minus bottom. The top one's 4 minus x. The bottom one's x minus 4. So 0 to 4, root 3 over 4. Top minus bottom, so that's 4 minus x minus x minus 4. And then I could let my calculator do the heavy lifting on that. Math 9, 0 to 4. Make it look fancy with the fraction if you like. Root 3 over 4. 4 minus x minus, careful with all the parentheses in here, make sure we're subtracting x minus 4. Or you could be the one that distributes the minus sign and then collects the middle terms. So it's like, where's the mistake most likely to happen? Are you going to make a mistake with parentheses? Or are you going to make a mistake with algebra? Hopefully neither one. So 4 minus x minus 4, and then all of that squared dx. $36.950. So that's adding up all of the triangles.
A little side note here. What if our answer choices were 32 root 3 over 3 and 64 root 3 over 3?
Like, how would we know which one it was? If you have a calculator.
Put them in the calculator just to figure out what
Just put them in the calculator and see which one matches. So there's no need to try to get fancy. Just
Match those up, and it ends up being this one.
But yeah, you're just going to put those in the calculator and see what the decimal gives you. Number 2.
Let S be the region bounded by the graph of 1 minus 2x and x squared minus 2. Again, I'm going to go with y1 and y2, probably because I'm going to the calculator soon enough.
It's also easy to tell which one is which, because one's a line, one's a parabola.
So there's y1. And the parabola would be y2. A solid has S as its base. Okay, so there's our base is that area.
We could find that area. And in fact, free response questions are almost always start with that, find the area, and then build a volume and find the volume. And the free response question on your test in a week is that same format.
Okay, cross sections taken perpendicular to the x-axis. We like that, so they're dx. Are semicircles. So semicircles. So volume is antiderivative.
It's got to be dx.
Can you read the intersections to know what my limits of integration are? I don't know that I can, so I'm going to verify that. I'm going to put both of those in the calculator.
Trying to make my window roughly match the window it gives me. That way my pictures will look similar.
I'm in a hurry, so I don't know if I want to trust that they meet at 1. Table would tell me that, though.
Yeah, they have the same value in x equals 1.
And I think they also meet at, is that -3?
Yeah, they have the same value at -3.
So from -3 to 1, I want to add up all of the semicircles.
Okay. It's 1/2 pi r squared, but what was the shortcut way we could do that?
Flip back over if you need.
What's the area if you know S?
Pi over 8 s squared. Okay, so once again I need to figure out what S is.
So S, that height, is just the top one minus the bottom one.
So y1 minus y2.
I've labeled them y1 and y2, so I can use y1 and y2.
I can also put pi over 8 out front. y1 minus y2 squared dx.
And now this is a calculator problem.
Pi over 8 -1 Math 9. -3 to 1. I can use y1 and y2 because my calculator knows who y1 and y2 are. I do need to put parentheses so that I square y1 minus y2. $13.404. Did you include the pi over 8?
Why did pi over 8 give me out of this?
Because pi over 8 is a constant, so it can slide in or out. It doesn't matter.
Why didn't you do that on the last one?
Forgot to. It doesn't matter. Yeah, that's a good question. Like, I left it in on the last one. I put it out on this one. It does not matter. And I don't even know, like, in terms of the calculations, is it 0.5 milliseconds faster one way or the other? Who knows? Doesn't matter. One thing I did want to say on this. If you got y1 and y2 backwards on this problem, and you got confused on which one was top and bottom, what would that do to your answer? If you switched y1 and y2, nothing. So some of these have a little built-in leeway there. If you get something backwards and you square it, it doesn't matter. So, kind of nice. Number 3. We'll set it up, maybe. It's exactly how far we got in second period, so just as well. Let R be the region bounded by those two graphs. All right, well, I know what x squared looks like. And in the interest of time, you can trust me on what the other one looks like. So there's that base area. Find the area of R. Oh, that's not even a volume problem. So that's... Is this a dx or a dy problem? Dx. So top minus bottom. The trouble for this one is I don't know where the limits are. So how will I find A and B? Yeah. Not guess and check. I mean, you could guess a few things, but they're not nice things, so it won't work. So calc intersect will give me A and B. And then I can tell that the top function is f of x minus g of x dx. That would be the area. We would just type that in the calculator and let him figure it out. Part B. If that is the base of a solid, cross sections perpendicular to the x-axis, yay, that's dx. Isosceles right triangles with a leg in R. So that's 1/2 s squared. Still be going from A to B. And S, that little length in there, is top minus bottom still. And I think, even though that's not a whole lot of work shown, or it feels like it's sporadic, that's enough work shown. Because if you've told me what A is and what B is up here, you just told me what S is, now you could go to the calculator and get an answer. Let's see, f of x is e to the negative 0.5x minus x squared, all squared, dx, whatever that is. But we need to stop there. Okay, so try worksheet number 2. Next time I see you is a block day on Thursday, so we'll have time we'll definitely have time Thursday to work some of this and then do the next topic as well. There's only one more new topic this whole year. Crazy.